So a few months ago, I posted a video called The Unexplainable Card Trick, and it received over 2.7 million views, and people all over the world have tried to figure out the method and how it works. This right here is the Unexplainable Card Trick Part 2. So the magician deals out 4 aces onto the table. The spectator can then shuffle the rest. We then place a few cards on top of each of the aces like so, and then we just get rid of the rest. We give these all a nice little square up, and the spectator can choose any 2 piles. It's a completely free choice. So let's go for these 2 here, and just to place them on top of the others, and then they can give these 2 packets a shuffle, and they can shuffle these as many times as they want. We then take them back and hold them in our hands, and the spectator can choose any pile to flip over. So it could be this one or that one. We're just going to use this one. And then we just alternate the cards onto the table, creating 1 pile. And you can see how mixed up these are. You can see the aces are all alternated differently. Square these up as well. And then we go back to the beginning and deal out 4 piles. And this is where we get a little bit more complicated. We just square these up, and then we're going to flip over each pile onto the other, just like that. Now, you'd have to agree, up until this point, everything is completely mixed. And this is the part that I just can't explain. When I snap, every single ace turns face up, which is completely unexplainable. Now, I'm going to show you how to do the trick, but I just can't explain how it works. Yo, what's cracking, everybody? Welcome back to the channel. So today I've got a really fun card trick for you. It is the Unexplainable Card Trick Part 2. Now, I'm sure there is someone on this planet that can explain how this works, but I, for the life of me, cannot. And what I'm going to do is I'm going to guide you through how to perform the trick, but I can't explain the mathematics behind it. So if you're ready to learn, smash the like button and let's get straight into it now. Okay, so I genuinely meant it that I'm going to teach you how to do the trick, but explaining it is a completely and utterly baffling mathematical solution. So if you just follow along, you will entertain yourself performing this. It is so much fun, and it's so bizarre how it all just happens.
Okay, here's an explanation for the Unexplainable Card Trick 2.0. Now, what I've done here to help us see what's going on, I've chosen red cards that have red backs. That way we'll know that they come from the left-hand pile. And then I've done a similar thing for the black cards. I've chosen blue backs. Okay, so that's true for the aces as well. Okay, so that will really bring to light what's going on within this effect. Okay, so I really just need to convince you of one fact. And once you understand that, it unlocks the whole routine. Okay, so we're going to set these face down, these face down. So once I show this first insight, we will then insert the aces as he did, and then do it a second time, and you can just see how all of it works perfectly. Okay, so he had the left pile, he had a right pile, and then he flipped over the right-hand pile. Now, what I'm going to try to convince you of is if we now alternate left, right, left, right, left, right with the cards, and then deal them out into 4 piles, and then perform this folding procedure, all of the movement of the cards, if we ignore the internal reordering of cards among the reds and among the blacks, it's equivalent to just taking the right-hand pile, reflipping it down, and setting it on top. All of the movement of the cards is equivalent to just doing that. And this is actually all you've done. So now in your mind's eye, you can picture the red aces facing up and the black aces facing up here, but I'll show you that at the end. Okay, so I have to first prove that. I have to prove that to you. Okay, so he flipped over the right-hand pile, and then we simply just alternate left, right, okay, all the way through. And because of the colors, you can kind of keep track of whether the card came from the left-hand pile or the right. Okay, and I think that makes it much clearer as to where the cards came from. And then what did he do from there? He just dealt out the cards into 4 piles. In fact, as we do this, you can see the cards being separated. This came from the right, left, right, left. Right, left, right, left, right, left. Okay, and then what does the folding procedure do? Well, you can fold from either direction, but I'll fold from left to right. Just in your mind's eye, try to picture what's happening with the cards. How are they being combined relative to color? Well, let's just take a look. Does that look familiar? Isn't that what I just showed you a minute ago? That this would happen? Okay, so let's go ahead and now we'll take out 2 black, and then we'll just kind of randomly insert the aces, and you can truly mix these like he did. He mixed the packets, that's fine. It won't hurt anything if you do that. And then we'll take out 2 of the reds, and then we'll put an ace there and an ace there. Okay, so what I've just shown you is that if you get to this point right here, which is what he did, if we now alternate left, right, and then deal into 4 piles and then fold the packets from left to right or right to left. In the case of the left to right folding, all of that is equivalent to just taking this and setting it on top. Well, you can kind of see what's going to happen. All of the aces are going to be face up, okay? And so we can go ahead and just repeat what we did earlier, right? This is like the whole routine now, his whole routine. Just go left, right. The only difference is we kind of judiciously chose card colors to help us keep track of what we're doing, of what's going on. Okay, that's all we did differently, really. And then from here, you just deal into 4 piles like that. And you can see how much more complicated it becomes visually when you have these up-facing cards and down-facing cards. And then just imagine these different colors. That's the key. All the black cards could be some red, some black. All of the red cards could be some red, some black. Okay, so visually it's going to look like a total mess. And now if you flip them, or fold them, I guess, and then we spread these, we're going to see that those 4 aces are the only ones face up. Okay, well, that is the explanation for it. The alternating of the left and right piles followed by this 4-pile dealing with folding from left to right or right to left is equivalent to just flipping, let's say, the right-hand pile and stacking it on top. And then it just becomes crystal clear what you would expect to happen. Okay, well, I hope that helps. And I also want to point out that his video that he mentions, the unexplainable card effect, that got 2.7 million views, I actually created a tutorial for that one as well. So I'll list those videos down below. So again, thank you for watching, and take a look at other videos on the Absolute Math Magic channel. Okay, I'm making this video in response to a LinkedIn group member's question. Okay, and so on my Math Card Magic LinkedIn group, I have a group member who asked a question about a card effect that claims that it's unexplainable. It cannot be explained. Okay, so let's go down to the video, and then we'll just play the performance portion of it, and then we'll talk about the video. Okay, so here is the post. So Mary writes, here is a supposedly unexplainable card effect, which has gotten over 1 million views in the first 2 weeks after it was published. The performer claims, quote, this trick cannot be explained. And then she goes on to say, I doubt that, but I don't think I fully understand what's driving this effect. Can any of you in our LinkedIn group explain simply and clearly why this card effect works? And then I replied to Mary, thank you, Mary, for your post and question. I want to give our group members some time to respond if they would like to before I chime in. And so that was over a week ago, and no one has responded yet. So this is the video we'll look at, and then we'll talk about the mathematics behind it and actually explain what's going on with it.
This is the unexplainable card trick, and honestly, this trick freaks people out. So this is all about intuition. You ask the spectator, I want you to cut, and use your intuition to see if you can cut exactly half of the deck, which they do so. The magician then counts them onto the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28. So not quite half, but you were using your intuition and you almost got there. The magician then explains to the spectator that he now wants him to shuffle these two piles together, which the spectator does. So once they are shuffled, the magician takes them back and deals 2 even piles of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the spectator can choose either this pile here or this one. It's entirely up to them. So let's say they choose this one. The magician then shows his card and says, look, you shuffle these any which way you liked. Actually, you shuffled the entire pack. Now I'm going to use my intuition and tell you exactly what these cards are, whether they're red or black. I'm going to use my intuition and tell you the first card is a black card, which it is. The second one is a red card. The next one is black. The next one is also black. My intuition tells me the next one is also black. The next one is red this time. The next one is black. The next one is black. The next one is red. And the last card, not only is it red, but it's the 10 of hearts. And that's a real miracle, freaks people out, and I'm going to show you exactly how it's done right now. Yo, what's cracking, everybody? Welcome back to the channel. So this is the tutorial for the trick that cannot be explained, and seriously, this freaks people out, and although I'm going to teach you the method can't even be explained. I will explain in a second, you'll see why. So it uses a principle called the Gilbreath method, and honestly, it's insane.
Okay, I don't know if any of you noticed the organizational structure of the deck when he had the cards face up and he was counting out how many cards were cut by the spectator, but it was clearly set up in an alternating pattern of red, black, red, black. Okay, so it's a cyclic packet, and so because of that, the Gilbreath principle can be employed if you perform a Gilbreath shuffle. Okay, so if you watch the whole video, he actually does explain everything that he does so that you can actually perform this for yourself. The only thing that he leaves open is his statement that the Gilbreath, he calls it the Gilbreath method, which is not how it's described. It's the Gilbreath principle. He says it's something that cannot be explained. Well, the reality is mathematicians have rigorously proven why the Gilbreath principle is true. And in particular, for an alternating packet, we're actually using what's called the first Gilbreath principle. That is the first principle that Norman Gilbreath discovered when he was working with alternating decks of red and black cards. Okay, but since then, rigorous proofs have been provided that completely explain and justify the outcome of a Gilbreath shuffle when performed on a cyclic arrangement of a deck of cards, or any objects, actually. Okay, so I guess I want to point that out. The Gilbreath principle is very well understood and has a solid mathematical justification that completely dispels any mystery as to what's going on and what the outcome will be for any Gilbreath shuffle. Okay, so let's just take a minute to kind of develop our intuition for what's called the first Gilbreath principle. Okay, so what Norman Gilbreath discovered is that if you have an alternating deck of red and black cards, so here it'll be red and blue magnets, and then if you deal any number of cards into a second pile from the top, any number whatsoever, which, by the way, it reverses the order of these cards, right? They're being reversed as we deal them to the table. And then you interlace them by way of a riffle shuffle. The resulting arrangement will consist of pairs of cards, when taken from the top, will consist of one red and one black in some order. And that's what drives the entire effect that we just saw. Okay, so I've reverse counted, we call it, just 8 cards here. Imagine these as cards. Okay, so a riffle shuffle has a very important property, namely the cards in one pile, like this pile here, they will maintain their relative order, meaning this card here, if it's a riffle shuffle, will never go above that one. Okay, the only way to do that is to like drop the cards everywhere. Okay, so as these interlace in some random fashion, we just need to remember that the order of these cards relative to each other will be maintained. The order of the newly dealt out pile of cards relative to each other will also be maintained. So if you look at what's happening here, what can the top card be? You know, as these come together in some way, interlace in some way, well, there's just 2 possibilities. The very top card could be red, right? Or it could be blue, the very top card, right? Maybe that one gets shuffled to the top, okay? Well, let's just look at what happens in each case. So let's say this one is the top card after the riffle shuffle. Well, what will the color of the second card have to be? Well, look, it's either going to be this card here that gets squeezed right in after that one, or this card here will be shuffled, riffle shuffled, and positioned into the second place of this shuffled packet, okay? So one thing you can say for sure is if this one's red, the second card will have to be, quote, a blue. There's no other choice, because all of these other ones do not change their position relative to the cards in each pile, right? Now let's take a look at what happens if this one happens to be riffle shuffled to the very top of the new packet that's been brought together. Well, look, what are the candidates for the second card in the new arrangement? It could be this one, or it can be this one. In either case, it has the opposite color to the very first card, okay? And so what you're going to find, in fact, let me just go ahead. In fact, maybe we'll kind of play this out for a few steps and you can see. So let's say maybe this one goes here like that. Now it's possible that this one goes next or this one. So maybe why don't we have it go right there for that next one. Well, look what's going to happen here. What's the color of the card that will have to follow it? The red here. It's going to have to be a blue. Okay, and so what I want you to focus on is focus on pairs. So this is like position 1 and 2, position 3 and 4. Okay, now for position 5, it can be either one of these. So maybe it's a blue, right? Blue there. Well, what's going to have to happen for the 6th card? It's going to be this one or this one. So it's a red, right? Okay, so let me just bring over more of a mathematical write-up. Here's a simple explanation of the consequence of Gilbreath shuffling an alternating deck of red and black cards. Okay, so just as we saw, for the first position, it can be either color. But once a card is put in that first position, let's say it's red, what we saw was the card that follows that red has to be one of 2 black cards. It has to be black, in other words. Whereas if the top card after shuffling ends up being black, then the second card will have to be red. It will have to have the opposite color. Now it's important to realize that for position 1, it's possible that the top card will be red or black. We don't know for sure. But once we know the color, we know that the second card will have to be of the opposite color to the new top card. That will be true as we go down in pairs. Okay, so when we go to position 3, as we saw in that little magnet illustration, the card in position 3 could either be red or black. Either one's possible. But once a card is set down, the next card, which would be in the 4th position, has to have the opposite color to the one in the 3rd position. And this will be true all the way down in pairs. Okay, so pairs taken from the top will have to consist of cards of opposite color. And that's actually what he takes advantage of within his performance there. Okay, so really the first Gilbreath principle, it was surprising when it was first discovered. I mean, it's still surprising. It made quite a stir at the time in 1954-55 when it was discovered, and the first, quote, card trick was published using this principle. So yeah, it had a big debut that really got the magical community excited about this new principle in mathematical card magic. But it is now well understood, and I'm hoping that you have a better idea now as to why it is the cards taken as pairs, starting at the top, will always have to consist of a red and black in some order. Okay? So anyway, I just wanted to kind of explain that, because really everything that he performs there is fully explained by him except for the implications of the first Gilbreath principle, which is what we've been talking about here. But that really is what makes that effect work. And perhaps there is one more thing I could explain in his video. I'm not sure if he really explains it. That if you have, here I have an alternating deck, red-black, okay? And so if we go ahead and reverse count, which is really what he did when he was counting how many are in each half, it was just a sneaky way to reverse a bunch of the cards without people realizing that you're reversing the cards as you count them. And then if you riffle shuffle these together, as we've seen here, what's going to happen is pairs of cards taken from the top, so maybe I'll just do this is equivalent to a riffle shuffle there. It's just kind of a messy ferrule shuffle, right? So cards taken from the top will have the property that every other card, every pair will consist of a card of each of the colors. So here, red, black, black, red, black, red, and so forth. And so if you realize it has that structure, when he dealt out the cards to the spectator, one for the spectator, one for himself, these are guaranteed to be of opposite color. Okay, these are opposite color, and so forth. Okay, so what this allows you to do then is you can use the information of the cards in your packet to deduce what the color of their card must be. Okay, so since ours is black, and we know that this is the kind of companion card to ours in terms of pairs taken from the top, this one would have to be red. Same thing here. If you know that's red, this one has to be black. Okay, and that's what he did, because when he spread them out, if you notice, he kind of put the cards back at the bottom of the deck here, back here, and then he was able to just, you know, surreptitiously kind of see the color of the corresponding card and then know the color of the spectators' cards in their little pile. So anyway, so it's a clever little Gilbreath principle performance. Hopefully that answers Mary's question as to, okay, what's really driving this effect. And if you want to watch the whole effect, now you know it's on our LinkedIn groups page, and you can learn how to do the effect and share it with family and friends. I'm sure they'll be as surprised by it as most anyone would be, except maybe those who have studied a lot of card magic. They would maybe see what's going on. So anyway, so thank you for watching, and I appreciate Mary's question, and I encourage you, and any of you, to take a look at other videos on the Absolute Math Magic channel, since I'll be posting this video on YouTube generally, as well as on my LinkedIn group page. So thank you again.
All right, guys, so here's an insane self-working card trick that literally anybody can do, and you can do it with a borrowed deck. There's no setup, and the spectator can shuffle these as many times as they want. So what you do is you hand them the cards and say, just take a few off the top, not too many because we haven't got all day, and tell them to count them in secret. So 1, 2, 3, 4, 5, 6, 7, 8, 9 cards. Say, put those in your pocket. And then what you're going to do, if you took 4 cards, you're going to count 1, 2, 3, and remember the 4th card. But before you do, give these a quick little shuffle. So obviously they've got 9 there, so they're going to count in secret. They don't do this out loud. So 1, 2, 3, 4, 5, 6, 7, 8. Remember the 9th card, all right? And they can put a few more onto the pile if they want to, just like so. And then you place those back. You get the cards from their pocket, place them on top, and you can instantly tell them what card they are thinking of just by doing this. So no, it's none of those, none of those, no. I have a feeling about this card here, and you can tell them straight away that that's their card every single time. The method's crazy. I'm going to show you exactly how to do it right now. All right, guys, so here's the explanation to this insane self-working card trick. Now, it's the Simon Aronson trick, and if you know who this guy is, you know he's an absolute freak, and he comes up with some, amazing stuff. So what you do is there's no setup at all. These can be shuffled by the spectator. They can take off as many cards as they want from the top. And so let's assume they take 6. You don't know how many they've got. Then what you do is you say, look, you're going to count, say if you took 3 cards, you're going to go 1, 2, and remember the 3rd card. But before we do so, you give them a shuffle, and then obviously they've got 6 here, so they're going to go 1, 2, 3, 4, 5, and remember the 6th card. And what you're doing here is you're actually counting in your mind how many cards they put on the table, because they can still deal some more on top and say, look, just deal some more on top if you want to. And let's say they put a few more. So we know there's 9 cards on the table. The method is just to plus 1. In your mind, just add an additional card. And so that brings us to 10. These go on top. These go back on top. So you say, take these from your pocket, put them on top. And you know now, if you count to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, their card will be at the 10th position, okay, or whatever number that they took.
Okay, I want to quickly go through a short mathematical explanation of the effect that Steve showed, which may help many people not only understand the effect, but be able to perform it more effectively. And then after I go through this, I'm going to show you another way to present this result that carries, I think, a much greater punch. And it's an easier way to perform the mechanics of the procedure and keep track of where you are. Okay, so hang in there to the end because I'm going to show you an alternate presentation that I think is more impactful. Okay, so what we did was we started with a deck. Now I'm using these B brackets, these square brackets. This is something that Norman Gilbreath did to help explain certain mathematical card effects. So it's a very effective way of focusing your attention on the essentials of what's going on so that you can see why something will always work out a certain way. Okay, so we begin with a deck of 52 cards, and then we have the spectator cut any number of cards. In the second half of the video I just showed, Steve had the spectator cut 6 cards, so you can think of X as 6 right here. And then from there, from the rest, now the ... just represents the rest of the cards in the deck. So it would be 52 minus 6 cards being represented here. But the quantity here is not really important for what we'll be doing. So from these cards, the spectator deals to the table 6 cards, 1, 2, 3, 4, 5, 6, and they remember the identity of the 6th card. Now I've notated it with this little label here, a 1 with an asterisk. I believe in the presentation it was the King of Clubs. We're talking about the second half of the presentation by Steve. So it was King of Clubs, the spectator's remembering, and then you had the remaining portion of the deck over here. And then Steve explains, well, the spectator's free to deal from here additional cards on top of their noted card. And so why don't we say the additional cards we'll call Y And in his video, it was 3 cards. So he dealt an additional 3 cards on top of the spectator's noted card, King of Clubs, okay? And then all of these cards were set on top of the ones over here. Now, in some way, suppressing all of this information, how many cards are below certain cards, because it won't matter to us. Okay, so that's what the ... is denoting. Okay, so that brings us right here. So the situation we're in is X cards, or 6 cards were cut. Y cards, or 3 cards, were set on top of the King of Clubs. And then the cut cards are set on top of the Y cards just dealt. So we'll have X, comma Y, or in other words, X plus Y cards. Here it would be 6 plus 3 is 9. We'd have 9 cards above the spectator's card, the King of Clubs. And so the rule he gave was to know the location of the spectator's noted card, you just take X plus Y, which is 9, and then add 1 to it. So you just do a plus 1, as he phrased it. And so the spectator's card is going to be in the 10th position, which happened in the video just shown. Now, the challenge with performing it this way is the performer will have to know both the value of the number of cut cards X and the value of the number of additional cards dealt on top of their noted card. So in other words, Y. So both quantities, X and Y, would have to be known to really perform it the way shown in the video. And that can be a bit tricky to determine the value of those in a way that's non-obvious. Okay, I'm going to show you another way to perform this underlying effect, but you will not need to know the precise value of X or Y to pull it off. And it really will look like an absolute miracle to the spectator. Okay, so what you do is you have the performer cut any number of cards that they like, okay, just as before. We can keep it the same if you like. Maybe they cut 6 cards, 1, 2, 3, 4, 5, 6. Now, you as the performer do not need to know the number of cards here. You will not need to know that. That's what's nice about this different way of carrying out this effect. Okay, so they've cut a number of cards. And so what you're going to do now is you're going to show the spectator the cards in each position. Position 1, 2, 3, 4. And when we get to position 6, which is the number of cards they cut, they need to remember the identity of the card in the 6th position. Okay, but you're going to continue showing cards 7, 8, 9, 10 because you're not sure exactly the number of cards they cut. But of course, you will need to show enough cards that the position of their special card is arrived at, determined by how many cards they cut. Okay, so for example, here we would be safe to show them, let's say, 13 cards, because surely if you look at this packet here, it's less than 13 cards. Okay, so you know it's at least as big as this. Okay, so this is card 1. Show them that. It's not theirs. 2, 3, 4, 5. Now this is the card in the 6th position, determined by the number of cards they cut. Now we don't know that, but as we're showing these, we're asking them to remember the card at their special position, determined by the number of cards they cut. So we'll go ahead and just put it face up so we can see it. But we don't know that that's theirs. And so you say 7, this is the 8th card, 9, 10, 11, 12, 13, let's say. Okay, so 13's plenty here. Okay, and then you just go through and do the same thing that we did before. You just take their cut cards, set them on top, and for a very similar reason to what I've shown here, their card is guaranteed to be in position 13 plus 1. So remember, I showed them 13 cards. If you just add 1 to that number, you will land on their card every time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then the next card is guaranteed to be theirs. And as far as they know, you know nothing. You have no idea how many cards they cut or even how many additional cards were set on top of their remembered card. You don't know anything, but yet you're able to locate their card with perfect accuracy. Okay, so I think that's a nicer way to carry out this routine because you don't need to know as much information, but yet you seem to pull off an impossible effect with virtually zero information. Okay, so thank you for watching, and take a look at other videos on the Absolute Math Magic channel.
All right, let me show you a really fun trick, and we're going to call it 4 coincidences. So what we're going to do to start off with is we're going to use the 2 aces as marker cards. And so what we'll do from here, so we'll give these a shuffle, and then what we're going to do is we're actually going to remove one card here. I won't show you what that is just yet, but we are going to leave it inside the card box, okay? So that's going to sit right there. So now what's going to happen is you're going to ask spectator number 1, because you're going to have 2 spectators here. Spectator number 1 is going to think of a number between 1 and 20. So let's just assume they think of the number 10. Now remember, you as the performer, you do not know this number. And so they count down to 10 cards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you as the performer can have your back turned while this is all happening, and then you say take one of those aces face up and just mark where you counted and place the rest on top like so. And then you hand the cards to another spectator, and let's say they choose a number between 1 and 10 and it's the number 7, and then they do the same. So they count 1, 2, 3, 4, 5, 6, 7. Ask them to mark that spot with an ace and place the rest on top like that. Perfect. So the magician then turns around and says, look, both of you could have chosen any number, and you did, and you've marked them with aces. So let's have a look at where your aces are. And so we're going to take the card that's immediately on top of each ace like so. Keep those in full frame there. And then we say to the spectators, look, you could have chosen any number between 1 and 10, right? Well, you ask spectator number 1 what their number was, obviously number 10. And spectator number 2, yours was number 7, perfect. So we're going to total those 2 numbers together, making 17. And so quite freely, the magician just takes the cards and counts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We landed on a queen of spades. Now, this trick is called 4 coincidence for a reason. So you counted to 10, you counted to 7, and you marked it with an ace. However, what's the chance of you landing on another queen? Coincidence? I think not. And you'll see we've got 3 queens, but remember this trick is called 4 coincidences. And remember there was a card in the box that I placed in there at the beginning? Well, if we take a look, you might find that this card here is also a queen. What a coincidence.
Okay, let's take a look at the mathematical explanation for this great effect called 4 coincidences. Okay, so what you need for this will be you can choose any marker cards that you would like. In the presentation, the 2 black aces were used. Some people would use jokers. That would be fine as well. Okay. And then 4 queens, all 4 queens. Okay. So let me just explain this notation here. I'm using kind of specialized notation that Norman Gilbreath introduced. They're called B brackets. Okay. So how you read this, the square bracket here indicates just a pile or a packet of cards. Okay. And so over here we have A, C inside brackets. It's referring to the ace of clubs, kind of in its own pile. A sub S for ace of spades, it's in its own little pile. Okay. And then the other cards, the way they need to be set up is you need to have the 4 queens at the top. Okay, so that's how he had it set up. He had the 4 queens at the top. Now the order of these queens doesn't really matter. But to get the exact same outcome that he got, I went ahead with the ordering that he used. Queen of spades, clubs, diamonds, and hearts. Okay, so they're at the top there. Okay, now to allay any suspicions the spectator may have about the state of the cards, because of course, you know, they could be set up, which they kind of are. He did kind of a false overhand shuffle in which you retain what's called the top stock. Here it's just the top four. But it's good to take about 10 to 15 cards. So what you do is you hold the cards in preparation for an overhand shuffle, and then you just pull off a good chunk of cards, block of cards like that. And then you just, go through from here. This is a genuine overhand shuffle. Okay, it's very messy. And that should really convince most people that the cards have been at least scrambled a bit. Okay. And then what he did was he looked through the cards, and of course he didn't show us what he was doing, but he was looking for the queens. Okay, the queens will be down here somewhere. The queens are right there. Sorry if I can show all four. Okay, so what you do is you identify the third queen from the top. Now the top of the deck is over here, so 1, 2, 3. That would be the queen of diamonds. So what you do is you take that, you don't show the spectator, and you put that on the table. This is going to be like our special prediction cards. Now the packet really should go back together like this. I mean, that's the order in which it was set up. But instead of doing that, you reverse the halves, or the portions, I guess. They're not really half of the deck here. And so what that will now do, let me just go to the next line here. I guess I should have advanced a little bit here. So this is after the overhand shuffle. We've moved the four queens kind of somewhere in the middle. Okay. And then what he did was he set aside this one card. You can put it inside the box there. The Queen of Diamonds. Okay. And then the state of affairs for the deck now will be that you have the Queen of Hearts on top, Queen of Hearts, and then you have the two black queens at the bottom, which you do. Queen of Spades, Queen of Clubs. And we still have our aces over here. Okay. So that's kind of the situation for the remaining cards right now. Okay. Do you remember what he did next? He asked for a random number from, let's say, spectator 1, a random number between 1 and 20, okay? And we'll go ahead and just use the numbers that he used. So let's say they choose 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then he dropped this one on top. Now remember, what's at the bottom here? We have two black queens, and in particular, the Queen of Clubs is at the very bottom. So when he set the whole packet on top like that, it just puts the Queen of Clubs face to face with the Ace of Clubs. Okay, so what we're looking at is the Ace of Clubs is gone, and it's because it's down here near the bottom. Okay, so we still have the Queen of Hearts, and now because we dealt out X cards, the way to think about that is the Queen of Hearts is one of the X number of cards, or here 10. So that would leave an additional X minus 1, or 9 cards above the Queen. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we'll arrive at our Ace of Clubs, which is facing upward, right? And then from there, we'll get the Queen of Clubs, and then the Queen of Spades. And then the other cards, we don't really care what they are. Okay, so that's kind of the state of the packet before the second spectator chooses a number between 1 and 20. Okay, so I'm just pointing out that we have this number. These cards are below that first Ace of Clubs. Now, when the second spectator freely chooses a number between 1 and 20, we go ahead and deal that out. So I think in the original presentation it was 7. So 1, 2, 3, 4, 5, 6, 7. You put the second queen, second ace, the Ace of Spades on top. Now, do you remember what we do? We take the entire deck and put that on top. Now that's going to put the Queen of Hearts face to face with the ace of spades, which is what we want, right? Okay. And now from here, let me set aside, now remember our special card over here is the Queen of Diamonds for the final stage of the reveal. I'm going to put it off entirely because I don't have a lot of screen space here. Okay. Do you remember what he did next? Okay. Well, it's going to be hard for me to do here, but I guess we can do it. Maybe. Oh, I think you can see it now. So he spread out, he ribbon spread the cards. And he said, okay, wow, let's look at our marker card, the ace of clubs, and the card face to face with it, like that. Oh, here's our other marker card, ace of spades. What card is face to face with that? I don't know. We'll find out in a moment. And then you just close this up. Okay, and that's important to kind of close it up as is. Don't rearrange the portions that are created by removing these two pairs right here. Okay, so before we pulled these out, we had the Y cards that were dealt to the table. We set the ace of spades on top, and then we put the rest of the packet on top. So right before we pulled out these pairs, this was the state of the packet or the deck. Okay, and now when you pull these out, so now we're creating these two little pairs that we'll set aside for later for the reveal. So you're just pulling those out. So essentially this will come out. Those two will come out. They come right over here. And then these two come out right over here like that. Okay. Well, just look at what's left. We'll have all of the cards that were above the Queen of Spades. Then we have this. These are gone. Remember, these are gone. So we'd go from here, jump over to here, which is the x minus 1. These are gone. So we would jump over here to the y, which is what we have right here. And now we have these two new little piles of 2 cards each right there. Okay. Now, to finish, all he did was, so we have the deck here. So this is what it looks like. The remaining cards here, he flipped them face up. Okay, well, what will that do? Well, if you flip this thing face up, it reverses the position of all of the cards. So we had Y cards at the bottom. Now we have Y cards at the top, followed by x minus 1 cards that were above. Now they're below. And then we had a Queen of Spades above these. Now a Queen of Spades will be below those. And then whatever cards remain. Okay. Now the important thing is look at how many cards, including the Queen of Spades, we have from the top. Well, we have the Y cards, and then we have x minus 1, and then the Queen of Spades counts as one card. Well, the total number of cards right here is x plus y, okay? So what we did then is we had the spectators identify, okay, what were your secret numbers? And of course, for the first person, it was a 10. For the second person, it was a 7. And we said, okay, well, let's go ahead and add those. 10 plus 7 is 17. So in our write-up here, it would just be x plus y, okay? And so what this means then is that with the packet flipped face up now, if we count down x plus y cards, that final card will be the Queen of Spades, okay? And so that's what we're doing here. So we have them add their numbers. It ends up being 17 in the particular routine. But in general, it would just be the sum of their 2 secret numbers. So we just count down 17, or x plus y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so the 17th card brings us to the Queen of Spades. Now, of course, that won't mean anything to anyone. Okay, it won't mean anything. They'll go, okay, because they haven't seen these other cards yet. They haven't seen the card inside the box, and they haven't seen these cards that are face to face with the aces or marker cards. Okay, and so you can say, wow, all of your decisions have led us to this particular card, the Queen of Spades. I don't know if that's much of a coincidence, but let's just check to see what cards are face to face with the marker cards where spectator 1 freely chose 10 cards to be dealt, spectator 2 freely chose 7 cards to be dealt, and that determined what cards are face to face. What are they? Oh boy. This is looking like a fair coincidence here. We got the 2 black queens. Okay, what about the other spectator? What did his secret number lead to? Oh, you've got to be kidding me. A 3rd queen? That's amazing. Well, as you know, the name of the routine is 4 coincidences. This is only 3. Oh, yeah. Do you remember we had a card inside the box? He had it inside the box, which is fine. Pull it out and say, wow, what do you think the chances are that this will be something surprising? Oh boy, I would say that is indeed surprising. Wow, 4 coincidences that I hope you can explain to me. That is amazing. Okay, so that is the mathematics behind it. A clever way to see what's going on is to use Norman Gilbreath's notation here for keeping track of quantities of cards that are above or below the location of other special cards and so forth. And it is certainly a routine that will surprise just about anyone out there except for maybe the most seasoned of card magicians. Okay, well, thank you for watching, and take a look at other videos on the Absolute Math Magic channel.